Hello, I am Dr. Themozhi, working as professor in the Department of Electrical and Electronics Engineering. I am going to deliver a lecture from the subject Communication Engineering in the topic Multiple Access Technique. Through channel, we are communicating both analog and digital signals. For communicating the data, we are using channels or medium. If you allot a channel for each user, for each one channel, then it will be very difficult for us to allot band of frequency. We have only limited band of frequency. In that, what we have to do is we have to allot channels. Instead of that, what we can do is we can allot multiple users or multiple techniques through a channel. This technique is called as multiple access techniques. The same technique is used in the mobile phones or mobile communication. Without multiple access techniques, we cannot imagine about the mobile phone communication. The mobile phone communication, we are at the time transmitting more number of channels, datas. More number of datas are transmitted through a single channel. So, the frequency allotment can be saved, at the same time also can be saved. That is why it is the very better technique called the multiple access technique. Without that, we cannot imagine the mobile communication at present we are having nowadays. See, we are enjoying the all the facilities available with the mobile phones, that is internet, speaking over one to another, and message, SMS, and WhatsApp communication, video communication, like all the communications can be done through a single channel with the help of this multiple access technique. We have three different multiple access techniques mainly. One is frequency division multiple access technique, the second one is time division multiple access technique, the third one is code division multiple access technique. See, we have another one called space division multiple access technique also, but in this presentation it is not given much importance to the code division multiple access technique and the space division multiple access technique. For multiple access technique, the three parameters have been considered. One parameter is frequency, the second parameter is time, the third parameter is code, or the third parameters can be taken as power. See, in the first frequency division multiple access technique, what has been done is the time and the power are kept constant, only the frequency is given for different allotments. See, for example, for a particular time period, the power of the signal transmitted is going to be constant, but the frequency allotted will be different. For example, for the first user, 10 kilohertz of frequency, and the second user another next 10 kilohertz of frequency. Likewise, the frequency will be segregated into different slots. For each user, different slots of frequencies will be given in the first technique. The second technique, we are going to keep the frequency and power constant, but the time given to each channel will be different. So, like what we used in the frequency division multiple access technique, here first user one time period and the second user next time period, second and third user third time period, like time will be slot into slots. So, in each slot every user can communicate with each other. But in both frequency division multiple access technique and time division multiple access technique, what we do is in between each slot we will give a guard band. We will provide a guard band. The guard band compared to the time slot or frequency slot given to each user, the guard band given will be very much less. So what the third one is, power is going to be same, time is going to be same, frequency is going to be same, but the coding technique used will be of different here in the third technique. For explaining the frequency division multiple access technique and time division multiple access technique, the better example we can consider is GSM. GSM is the global system mobile for mobile communication. Without that we cannot imagine the present communication which is taking place. In that GSM technique we are using both frequency division multiple access technique and time division multiple access technique. For example, in frequency division multiple access technique, the bandwidth allotted in GSM is 25 megahertz. Each will be the 25 megahertz bandwidth will be segregated into 124 carrier frequencies. Each bandwidth will be separated with a 200 kilohertz apart. In between we will have a guard band also. Like the same, different time slots also will be given. That's why it is using both time division multiple access technique and frequency division multiple access techniques. We have already known about the carrier. What is carrier is, we are using carrier for modulating the message signal. The carrier will be of high frequency because we could not send the message signal as such. If we send the message signal as such, what will happen is we require a very big, very high antenna. In order to avoid it, to reduce the antenna height, we are only imposing the message signal characteristics on the carrier signal. So here I said we are having 124 carrier frequencies that are given with a slot frequency of 200 kilohertz, and then in the time slot also we have 8 time slot per channel. So for a single channel 8 time slots and 124 carrier frequencies are allotted in the GSM technique. Before going into the multiple access technique, we will see what is multiplexing. That we have seen already in our earlier semesters. Multiplexing means we are multiplexing 2 power n number of channels into a single channel in the transmitter end. In the receiver end, what we do is the opposite process of 1 into 2 power n number of messages or signals. So for that we use a multiplexer in the transmitter end and the opposite device which is demultiplexer in the receiver end. The figure shows the one link in the one link 4 channels are combined. So in the transmitter end we have 4 channels, that 4 channels are combined into one link and in the transmitter end, and in the receiver end the one link is separated into 4 channels in the using the demultiplexer. In this slide, one example is given with telephone channels for explaining the multiplexing and demultiplexing operations. We have 3 users, telephone users are there in the transmitter end, and 3 other users or receivers are there in the receiving end. The 3 users channels or 3 users or 3 channels are combined into one link using the multiplexer, and in the other end, receiver end, the one channel combined for 3 one link combined for 3 channels are again separated into 3 channels in the receiver end. This is what happening in the telephone conversation or telephone communication. See this slide, explains us if multiplexing is not happening, what will happen? We have to use, see, 4 different devices are there in the transmitter and 4 different devices are there in the receiver. Like the same in the other in the diagram B also, we have 4 devices are in the transmitting end and 4 devices are in the receiver end. But in the first slide, without making multiplexing, how many channels are required? You see, we require 4 channels. So, for each channel we have to allot time period, frequency, so medium. So, all those things will be wasted. Instead of that, if you go for multiplexing, for 4 channels itself, we are going to use one path. So, what we can do is, we can save the bandwidth as well as the time period. This slide explains us the frequency division multiplexing technique. We have the host in the transmitter side and the receiver side, we have 3 computers. So, through computer network, we are going to communicate. See, for that we are going to use a frequency division multiplexing technique. So, the 3 coast are 3 informations or 3 signals will be combined with the help of frequency division multiplexing technique. For each user or each signal, a frequency bandwidth will be allotted. So, frequency range of frequency will be allotted. First range of frequency, second range of frequency, third range of frequency. In between, a guard band should be allotted in order to avoid the intermodulation or crosstalk. In the receiver side, again we have a demultiplexing device that will divide each thing. Whatever we combined in the middle will be segregated or separated out, that will be communicated to the 3 devices which are available in the receiver end. In this slide, the advantages of multiplexing is given. So, more than one signals can be sent over a single channel, and then effective usage of the bandwidth of the medium can be used with the help of multiplexing. Without using multiplexing, effective usage of medium and time will not be available for us. So, by using multiplexing technique, we are saving the bandwidth provided to us, as well as many users can be transmit or receive signal with effective usage of channel. Actually, as I said earlier, in GSM we are using FDMA and TDRMA. I told. In the FDMA is mainly used for in GSMA, voice and data transmission. It is analog in nature. It is analog technique. Analog technique in the sense the signal used will be continuous in nature. So, the message or voice or data will be of continuous. It will be always present. In FDMA, total bandwidth is divided into non-overlapping frequencies. It is given in the previous slide. For each channel, a band of frequency will be given. In between each band of frequency, a guard band will be provided. So, we will not have overlapping of frequency in between each band of frequency allotted for each channel. So, each user is allocated a unique frequency. That means the users using the frequency will be unique for each channel. For example, in FM radio, for each radio station, a band of a frequency will be allotted. For example, for Suryan FM, one frequency, that means it will range in between a particular band. For another radio station, one particular frequency band will be allotted. So, each radio station can communicate through a medium at a particular time with the help of this technique. Like the same in video communication also, in GSM also this technique is used, I told, for voice and data transmission. So while using mobile phone also, for different techniques, different frequencies will be allotted. So using that, what we can do is, through the same medium different signals can be transmitted with different slot of frequencies. After that, these channels are assigned on demand to user who requests service. That means only when the user demands, the service will be provided. If the user is not demanding at the time, the channel or the user will not be given the provision. The channel will be provided to the band of frequency will be provided to the other user who is requesting it. During the period of call, no other user can share the channel, particularly which is used now by the user who is demanding on it. Like the same, how we communicate between two devices through telephone nowadays. See, if two users are communicating in between two devices, at that time the second user cannot communicate in between, but we have now facility to bring other user also inside because of update in the technique nowadays. But through the telephone conversation, only two users can communicate at a time using this frequency division multiple access technique. Channels are provided with Broadband. This has been I am insisting again and again, because no overlapping happens because of providing this Broadband. If we are not providing Broadband, what will happen is we will get intermodulation. Because of this, that overlapping happens. So in order to avoid this, we have to provide Broadband between each frequency band allotted for the users for a particular channel. This diagram gives the three-dimensional view of the frequency division multiple access technique. The time period is given in the Z axis, the code is given in the Y axis, the frequency is given in the X axis. The frequency bandwidth is divided into different channels. Each channel will be used for different users. In between, Broadbands will be there, that is not given in this figure. So here the code and time are kept constant, only the frequency is segregated or separated into slots. So here the other two parameters are kept constant. While we are going for multiple access technique, we have to consider three parameters. I told the three parameters are code, time and frequency in each multiple access technique. For example, in frequency division multiple access technique, frequency is going to be the varying parameter, the other two parameters will be kept constant. What are the advantages of the FDMA is listed out here, that is why we are going for FDMA. For which system it is suitable also we will understand from the advantages listed here. FDMA is relatively simple to implement compared to the other two multiple access technique. FDMA is usually implemented in narrow band, that means the frequency bandwidth allotted is very narrow, there you can go for FDMA system. And then here synchronization, we need not to bother more about the synchronization, whereas in time division multiple access technique the synchronization required is more complex, but here the absence of synchronization is allowed here. The complexity of FDMA mobile system is lower when compared to the TDMA system. That is why mostly the mobile communication systems we use FDMA compared to TDMA technique. See, we have seen the advantages of the system. What are the problems we have with FDMA technique? We will see now. As I told you already, we will have modulation, cross modulation we will have, I told. So, because of cross modulation or overlapping of frequency bandwidth, we can have crosstalk. So, the intermodulation will distort the signal, and then it is not suitable for multimedia communication. So, we are in multimedia communication, we are avoiding FDMA technique. Okay. Next importance is given to the TDMA. As I told you already, in GSM we are using both FDMA and TDMA, I told. I already explained you about FDMA technique. Now, I am going to explain about TDMA. In TDMA, the frequency is going to be constant, but what we are, channel link is not divided on the basis of frequency. We are going to divide the link or channel into more divisions, but it is not based on the frequency, it is based on the time slot. So, each user will be given different time slots. Time slot in the sense, we cannot think that much time period will be given to each user. A very little, you cannot think microseconds of time allotment will be given to each user. So, each user will be given different time slot. If for example, if 8 users are there, first user will be given the first time slot, second time slot, third one, fourth one, like will come up to 8th again. It will start from the first to 8th, likewise it goes. After that, total time available in the channel is divided between several users. So, in the frequency division multiplexing, we use different frequencies, but there we use much time period, but here we are going to use the time period effectively. Each user is allotted a particular time period, means the total message will be separated into different time slot or slices. So, each in one circle, one slice will be communicated, the next slot, the next slice will be communicated, likewise it goes. From this diagram itself, we are able to understand the difference between TDMA and FDMA technique. In that one, we used a single channel, only a single line is given, parallel lines, one wire like line is given, but here the same channel or the parallel lines or a cable has been divided into 4 slots. We have 4 users in the transmitter side and 4 users in the receiver side. First user will be allotted at the first time period, second user at second time period, third, fourth, likewise it goes. So, the first user time slot, what information has been transmitted will be transmitted to using the demultiplexer, first one, second one, third one, fourth one, it goes like that. For that we have a multiplexer in the transmitter side and a receiver in the receiver side we have a demultiplexer. So, using that what we can do is we can give different time slot for each user. So, here we are going to use the time effectively, there we used the frequency bandwidth effectively. Actually, this is similar to the 3-dimensional 3D diagram which has been shown for the FDMA. In FDMA, I told we are considering 3 parameters. For TDMA also, for every multiplexing technique we are considering 3 parameters, I told. In all the 3-dimensional diagrams for multiple access technique, we consider x-axis for frequency, y-axis for code and z-axis for time period. See, in the FDMA, your time period and code are kept constant, only frequency has been divided into different slots, but here the z-axis is separated into different slots, but frequency and code are not separated. So, for channel 1, channel 2, channel 3, likewise we have n channels. N channels are provided with different time slots, which has been clearly explained or understood from this 3-dimensional diagram. As I told you already, the message means the whole message is transmitted. For the time will not be allotted for the first user, and for transmitting the whole message for the second user, third user, fourth user. It is not like that. What will happen is the message we will separate it into different different frames. The first user frame will be transmitted in the time period allotted for the first user slot, and the second frame, third frame, fourth frame. After that, second user frame 2 frame, second user, first user frame 2, second user frame 2. Likewise, the message will be separated into or segregated into different frames. The frames only will be transmitted. For each frame of every user will be allotted time period. So, we cannot find the time allotted for different user, because it is happening very faster. So, we cannot realize the time period utilized for the different users at a different period. It is the advantage of this TDMA technique, because it is going very fast, that could not be imagined. In order to have the synchronization, the frame, each frame will have a particular slot of message, and the other things which is mentioned as SN, SN-1, S1 are for synchronization purpose also. So, like we provided guard band in the FDMA technique, here we provide synchronization bits in the TDMA technique. So, we divide the message into each frame, and then every frame will be divided into bits. So, in each frame we will have some bits allotted for the message and some of the bits for synchronization purpose. See, as we have seen the advantages and disadvantages of the FDMA technique. Every system has advantages and disadvantages. What are the advantages and disadvantages we have with TDMA, we will see from this slide. Users make use of non-overlapping time slots. TDMA uses different time slots for transmission and reception. That means we know already what are duplex system. Duplex in the sense, at a time we have to transmit and receive, but here different time slots are given for transmission and reception. So, we do not require a duplex system. The power efficiency of TDMA system is better than the FDMA system. What are the disadvantages we have with this? In FDMA we provide guard band, that is why we can avoid crosstalk, I told, but here synchronization is a very big problem. With that, avoiding crosstalk will be very difficult. Here there is a need for increased bandwidth, because here we are allotting different time period. That is why we have to allot increased bandwidth as a result of high burst of data. What I told is, the data will be divided into different frames and then into bits, I told. So, we are bursting data, so we have to allot a very high bandwidth. That is the two disadvantages, major two disadvantages we have with this TDMA technique. Thank you.